Section 7.1, Simplifying, Multiplying, and Dividing Rational Expressions. The first thing you need to understand is what is a rational expression. Well, rational expressions are just fractions. Although you have to understand with rational expressions, you are going to have variables in the denominator. So that's what it means to be a rational expression. Have fractions, but again with variables in the denominator. So the first thing we want to be able to do is to reduce or simplify. To reduce or simplify, you must factor because you have to have multiplication to be able to cancel. So this is a section in the chapter that I would write note cards because a lot of the steps are very similar, but you don't always start them off the same way according to what the directions are asking. So I would write this on the front of the note card, to reduce or simplify. And then on the back of the note card, I would write what I'm supposed to do to start off. The first thing is to factor the numerator and the denominator. So that would be the first step. Because most students, once they get the first step started, they can do the problem. It's knowing what to do to begin with. So again, write the direction on the front to reduce or simplify. So write that on the front of the note card. And then write these couple of steps on the back of the note card. And quiz yourself over when you see this direction, what should you do? So then, after you factor the numerator and the denominator if needed, we'll talk about what it means why I say if it's needed. Divide all common factors that appear on top and bottom. So divide all common, or you can say like factors, right? You can say like factors that appear on top and bottom. So what I mean by divide is you're going to cancel those out. Now, when do you need to factor? Okay, that's if you have plus signs or minus signs. So you can only divide things out, which means cancel, when you have multiplication. So think of glue when you have plus signs and minus signs. If you see a plus sign or minus sign, you can't cancel individual terms. The whole factor is going to have to cancel. So for example, on number 1, again, reduce or simplify is the same direction. 32c squared d to the 6th over negative 24c to the 4th d to the 7th. There's no addition or subtraction here. Because I have all multiplication, I can go ahead and start canceling. So remember back in the day when we talked about powers, when we are dividing, what do we do to powers? Well, we subtract. So 4 minus 2 is c squared, and c squared is going to be left on bottom because there were more c's. And then d to the 7th and d to the 6th, you're going to have d to the 1st left on bottom as well. Now, according to rules, when we're simplifying, we never want a negative left in the denominator, so we'll move that up to the top. And 32 over 24 can be reduced by 8, and 8 can go into 32 4 times, and 8 can go into 24 3 times. So my final answer would be negative 4 over 3c squared d. You don't need to show the 1 as a power because it's understood to be there. So on number 2, x squared plus 3x minus 18 over x squared plus or minus x minus 6. Do not cancel the x squares. You cannot do that because why? We have plus signs or minus signs. We got to think of glue. So what's the first thing we should do? Factor. So when is it needed to factor? When you have plus signs and minus signs. If you have plus signs or minus signs, you must think to factor first. If you don't, you can start dividing common factors that appear on top and bottom. So we're going to need to still know how to factor very well. This is your C method. Factors of negative 18 that add up to a positive 3 would be x plus 6 and x minus 3. And factors of negative 6 that add up to negative 1 would be x minus 3 and x plus 2. Then we're going to divide all common factors that appear on top and bottom. So we're going to divide out the x minus 3's, and we're left with x plus 6 all over x plus 2. Do not cancel the 6 and the 2. You have plus signs. Those are glued. To be able to cancel, you would have to cancel the whole x plus 6 and the whole x plus 2, and you cannot do so. So again, you can only cancel when you have multiplication. So number 3, x cubed minus 8 over x squared minus 4. Again, you have to know your factoring well. This is your cubes formula. So go back and look at your cubes formula if you don't remember. The top would factor into x minus 2, x squared plus 2x plus 4. All over, x squared minus 4 is a difference of squares, so x plus 2 and x minus 2. Cubes formula, difference of squares formula. Go back and look at them if you don't remember. So what do? We cancel any like factors that appear on top and bottom, divide them out. So the x minus 2's divide out. And we're left with x squared plus 2x plus 4 all over x plus 2. Remember, once you use your cubes formula, you would not be able to factor that any farther, so you were done. Number 4, x minus 4 over 4 minus 6. Number 4, x minus 4 over 4 minus x. It doesn't look like we can do anything. We do see plus signs or minus signs, so we have to think factor. We can't factor these, and they're not the same. Because if I rewrite the denominator, the numerators as is, and I put the negative x plus 4, just rearranging, those are not the same. But as you can see, they are complete opposites. So what happens is we can actually take out a negative 1, so we're factoring out a negative 1 from the top. When we factor out a negative 1, the signs change, and we'll keep the denominator 1 just as is. So now, because we factored out the negative 1, we do have a common factor on top and bottom, and those can be divided out. So those do cancel, and I'm left with negative 1. That's kind of called the negative 1 trick. So be aware that if all your signs are complete opposite, factor out a negative 1, and hopefully you can still cancel. So for example, on number 5, we have 1 minus y over y squared minus 1. Again, what do we need to do? Well, you need to think about factoring because we see plus signs and minus signs. The top cannot be factored, but I'm going to rewrite it with the y first. And the y squared minus 1 can factor into y plus 1 and y minus 1. Now that I have factored the denominator, I can see that the numerator has factors that are complete opposites. So I'm going to take out a negative 1 from the top, and I'm left with y minus 1. And the denominator, I'll keep them just as is. So I'm doing that negative 1 trick. Because I factored out a negative 1, I do have a common factor on top and bottom, so I'll divide them out. And I'm left with negative 1 over y plus 1. So number 6, x cubed plus 1 over 3x squared minus 4x minus 7. This is your cubes formula. This is our AC method. Again, we have to know our factoring well. The cubes formula just tells me this is x plus 1, then x squared minus x plus 1. Go ahead and look at your cubes formula if you don't remember. This denominator, you're going to have to do the AC method. I'm going to jump to the answer, but you probably should show the work to get there. So we're going to have a 3x and an x. And let's see, we would need a 7 and a 1 here, with the outer being positive and the inner being negative. So if you do the AC method, this would factor into 3x minus 7 and x plus 1. Any common factors on top and bottom we can divide out. Yep, the x plus 1s. So I'm left with x squared minus x plus 1 all over 3x minus 7. So I'm assuming you know how to factor well. Make sure you're showing the work on how to factor those. So now we're going to learn how to multiply and divide. Well, if you think about how we do fractions just with regular numbers, then this isn't so bad. But if all you're using a calculator to do fractions, this chapter is going to be difficult. You need to understand fractions well with just numbers, because now we're doing things with lots of variables. So how are we going to multiply? Well, the first thing you want to do is factor. So this would be note card number 2. This would be note card number 3. Because when it says to multiply, you really don't start off the first step as multiplying. Same thing with dividing. That's not the first step. So put this on the front of the note card, start writing the directions on the back of the note card, and quiz yourself. To multiply, the first thing you want to do is factor the numerators. So all the numerators and all the denominators. Because you have multiplication, you can just start off by factoring. And then you're going to divide all like factors, so again common factors, that appear on top and bottom. So divide them out, they're going to cancel. Then the last step is to multiply any remaining factors. So do you see the last step is to multiply? So going through these directions again, factor the numerators and denominators if needed. Again, why do we need? If we have plus signs or minus signs. Always think of dividing things out, which means to cancel, when you have multiplication. If you don't have multiplication and you have plus signs or minus signs, think of that as glue, so they're glued together. Now, when I think about dividing, if I had 2/5 divided by, say, 3/10, I would never take a fraction divided by a fraction. I change division to multiplication and I flip my second fraction. Again, if all you do is take this and type this into your calculator and get an answer, you don't really understand what's happening. So you need to understand it with these numbers so we can do it with the variables. So what do we need to do? We need to change division to multiplication. Division to multiplication. Then we need to flip the second fraction. So we're going to flip the second one like we just showed. And then all you got to do is use multiplication rules. So you're back to multiplication. So do we ever really divide? No. We follow the rules of changing division to multiplication, flip the second fraction, and use multiplication rules. So what I would do on the test is I would go through and make sure you highlight a division sign. So you remember you have to do a little bit of work before you start. So on number 1, because it is multiplication, there are no plus signs or minus signs, so there's no factoring necessary. You can either multiply straight across, or you could cross cancel, or anything like that. I like to multiply straight across to combine all my like terms. So I'm going to go ahead and multiply 8 times 18, and that's going to give me a 144. And when I multiply, I add powers, so a times a is a squared, and b cubed times b cubed is b to the 6. Again, when you multiply, you add powers. And then if I do 9 times 16 in the denominator, I get 144 as well. A squared times a squared is a to the 4th because you add powers. And b times b squared is b cubed because, again, you add powers. So then, because we have no plus signs or minus signs, we can go ahead and divide any common factors. So 144 is gone. When you're dividing, you subtract exponents, so I end up with an a squared on bottom. And when I am dividing, I subtract exponents, so I get b to the 3rd on top. And that's it. Now, number 2, we see plus signs or minus signs. So the first thing you should do is go ahead and start trying to factor. Are there factors of 1 that add up to 5? No. So that factor stays as is. Can you factor 4x minus 4? GCF. Take out a 4, and I'm left with x minus 1. On the other fraction, x minus 1, can't factor it. Leave it as is. Factors of 1 that add up to 5? There are none. So I'll leave as is. I can go ahead and put them all together with one line because it was all multiplication. So now we're going to divide out any common factors. We have an x minus 1 in common, and we have this trinomial in common. So don't tell me the answer is 4. The answer is 1 over 4. Because why? The 4 is in the denominator, so what has to be on top is a 1. So on number 3, I'm going to let you try it out, and I will give you the answer, but what I want to show you first off to do is change division to multiplication, and we have to flip our second fraction. So we're going to change division to multiplication, flip the second fraction, but leave the first fraction unchanged. And then all you got to do is factor everything you can factor, and then divide out any common factors that appear on top and bottom. So I'm going to tell you what's left. So your final answer, you're going to show a lot of work, and your answer is going to be x plus 4 times x minus 2 all over x plus 6. You could leave it like that because I don't mind the factored form, but really the last step was to multiply out. So in reality, you should multiply those out, and you would get x squared plus 2x minus 8 over x plus 6. On the test, I will accept either one. My math lab might also, but if they do want you to multiply out the remaining factors, because that was the last step, multiply any remaining factors, then go ahead and multiply out those two factors. So see if you can get to that answer, and check and make sure it's okay. Alright, so let's do number 4 together. On number 4 we have, that wonderful AC method. Now, I want you to realize this is AC method, this was AC method, this was AC method, and this is that -1 trick. So you get a lot of little things going on here. Now, I'm not going to show all the AC methods. You're going to have to be able to do it. So I'm going to jump to the answers of the AC method for the first one. So 3x squared minus 17x plus 10 should factor into 3x minus 2 times x minus 5. Show the work on how you get there. Make sure you can do that AC method well. If you have questions over the AC method, get with me. So now factors of 3x squared plus 7x minus 6 would be 3x minus 2 and x plus 3. The 2x squared plus x minus 15 actually factors into 2x minus 5 and x plus 3. And I can see that this is that -1 trick, so I'm going to factor out a -1, and I'm going to be left with x minus 5. So I'm going to take out that -1 trick so I can get an x minus 5. Now I'll divide out any common factors that appear on top and bottom. X plus 3's are gone, x minus 5's divide out, and 3x minus 2's divide out. So what am I left with is 2x minus 5 all over -1. But don't leave that as your final answer. We don't leave the negative in the denominator, and we don't need the 1. So bringing it to the top and distributing it out, we end up with a -2x plus 5. So make sure you don't leave that negative down in the denominator and bring it up. So number 5, I'm going to let you do this one. I'll tell you this is your cubes formula. This is just your C method. This is your AC method. And this is your difference of squares. Show all the work and your answer should turn out to be 2x minus y. So see if you can get to that answer by doing the factoring. Alright, so let's look at number 6. We have a cubes formula, difference of squares, AC method, AC method. So a lot of work to do here. So if I do the cubes formula with the 27x cubed 8y cubed, that comes from a 3x, this comes from a 2y. So following my formula, I'm going to get 3x minus 2y, then 3x squared would be 9x squared, plus 3x times 2y is 6xy, and then 2y squared is 4y squared. So that's just the AC method, or sorry, the cubes formula for that first one. 9x squared minus 4y squared is a difference of squares, so that would be 3x plus 2y and 3x minus 2y. In this numerator, this is that AC method, so again you're going to need to show some work on the AC method, but I'm going to go ahead and say I know this is a 2x and this will be an x, and then with the 12 I need a 4 and a 3, but don't forget we need a y next to it, so then that's going to be a negative and that's going to be a positive. So they get 2x squared out, it gives you -8xy plus a 3xy, and then last gives you -12y squared. So let me rewrite this so you can see that a little bit better. That was going to be a -4y. Okay, so then here again, this is your AC method, so be aware of that. In your AC method, we're going to factor this as well, and that's going to be in a 3x and a 2x, and then probably a 2 and a 3 as well. So a 3x, I'm sorry, 3y and a 2y with a positive and a positive. So AC method again, show the work to get to that answer. I went ahead and jumped to the answers. Now we're going to divide out any common factors that appear on top and bottom. We have a 2x plus 3y. We have a 3x minus 2y. And it looks like that might be about it. So we're going to have a lot left over here. So on top, we're left with a 9x squared plus 6xy. Oh, that's why. I need to change division to multiplication and flip. Aw, man, I messed up. I am so sorry. Didn't even look at that. Division should become multiplication. So let's rewrite this. So my 3x minus 2y, and then 9x squared plus 6xy plus 4y squared. So nothing on the first one's going to change. That still stays as a 3x plus 2y and a 3x minus 2y. Don't do what I just did, right? Look at your symbol. This is a division. So then we're going to flip our second fraction. So on the second fraction, this will actually be on top. So we're going to have a 3x plus 2y and a 2x plus 3y. And in the denominator, we're going to have the 2x plus 3y and the x minus 4y. So all the factoring was correct. I just accidentally did not see that I had division, so my bad. All right, so everyone makes mistakes, right? So now what's going to cancel on top and bottom? We have a 3x minus 2y, we have a 3x plus 2y, and we have a 2x plus 3y. Good. I was thinking, wow, that's not going to have a lot of stuff that cancels, and normally we should. So then what do we end up with on top? Well, we end up with on top, see if I can fit this in, 9x squared plus 6xy plus 4y squared, all over the denominator, x minus 4y. So, change division to multiplication, flip, and it turns out a whole lot nicer. Alright, so now the one thing we have to be careful about is rational functions. And with rational functions, you got to be careful because you never want the denominator in a fraction to become 0. So be careful on that. So if I wanted you to find specific value, say for example g of 0. Well, if I wanted you to find g of 0, that just means I'm going to plug in a 0 wherever I see x. I always use parentheses when I'm doing a substitution because you might have to distribute, you might have to raise it to a power, so make sure you're using parentheses. 0 minus 2 is negative 2, 0 minus 1 is negative 1. Don't leave it as negative 2 over negative 1. You can simplify farther, and that just becomes g of 0 is 2. So now let's find g of negative 2. So g of negative 2 would be negative 2 minus 2, all over negative 2 minus 1. Well, negative 2 minus 2 is negative 4, and negative 2 minus 1 is a negative 3. And two negatives make it positive, so g of negative 2 equals 4/3. So we're just making sure we can do some evaluations. Now, what about g of negative 1? Well, g of negative 1 would be negative 1 minus 2, all over negative 1 minus 1. Well, that would give you negative 3 over negative 2, so we end up with positive 1. If I look at g of 1, I'm going to get a 1 minus 2 all over 1 minus 1. I get a negative 1 over 0. Don't leave it as negative 1 over 0. This is not correct. You can't have 0 in the denominator of a fraction. So g of 1 is undefined. So make sure you understand with 0 in the denominator, your fraction is undefined. So g of 1 is undefined. So I'm going to give you the answers to your next problem. Make sure you can get these correct. So h of 5, when you plug in a 5 here, a 5 here, a 5 here, and a 5 here, and all work it out, you should get a 0. H of 2 should equal negative 9 over 20. And h of negative 2 is undefined. So this is leading us into what it means to be a domain. So this is your next note card. Steps to find the domain on the front of the note card, how we do it on the back of the note card. So what does domain mean? Please make sure you understand this well, especially if you're going into college algebra, because this is one of the things that you do constantly in college algebra is we'll talk about domain. So the domain is a set of input values like our 5, our 2, our negative 2. So it's a set of input values we are allowed to use. You're allowed to use them if you can plug them in and they don't become undefined. So you're allowed to use any value except for the ones that make your denominator 0. So how do we figure out what our domain is? Well, the first thing you want to do is take your denominator and set it equal to 0. Solve that equation, but then you need to exclude those values found in step 2 that make the denominator 0. You have to exclude them, get rid of them. Now, do we care about the numerator being 0? No, we love the numerator being 0. We just don't want the denominator to be 0. So remember, write this on the front of the note card. What are you supposed to do to find the domain? Well, you take your denominator you set it equal to 0, add over the 2, so the only value you can't use is 2, because that would make the denominator 0. So with set notation, if you haven't seen set notation, it's these little squigglies, and you're going to say the set of all x's, that just means every single number. Draw your line down. Your line down means such that, and then x cannot equal 2. So all the numbers but x cannot be 2. That's what your domain is. So you can use every other x value, negatives, decimals, fractions, 0, everything. You just can't use 2. So number 2, I'm going to let you do that one. And I'm going to tell you what the domain is. It's a set of all x's such that x cannot equal 5 or negative 5. There are 2 values that you can't use there. So we're going to do number 3 together. State the domain. We take x cubed plus 4x squared minus 21x, and we're going to set it equal to 0. We'll take out the x. We're left with x squared plus 4x minus 7 equaling 0. I'm sorry, 21 equaling 0. All I did was take out an x because that's what was in common. Factors of negative 21 that add up to a positive 4 are going to be x plus 7 and x minus 3 equaling 0. So this means there's 3 values we don't want. We don't want x to be 0, we don't want x plus 7 to be 0, and we don't want x minus 3 to be 0. So this is one answer we don't want. Subtract over the 7. This is another answer we don't want. Add over the 3. This is another answer we don't want. So there's 3 values we can't use. So the set of all x's such that x cannot equal 0, negative 7, and 3. So there's 3 values we have to get rid of. But we can use every other value, positives, negatives, fractions, decimals, 0 we can't use, but we can use anything close to 0, close to negative 7, close to 3, but we can't use those 3 values. That's how you find the domain. Make sure you know how to do it for the test. So again, just take all your factors once you have factored them and they equal 0, solve each one, and then throw those values out. So we're not keeping those values that make the denominator 0.